So this paper that actually March is about to present is we're inspired by actually, we have teachers that are actually writing hit messages and explanations inside our platform called ASSISTments that has 300,000 students using it. And so we're trying to actually figure out how to crowdsource something. And so I'm going to let March actually take it away, and then maybe actually I'll come back and say some closing words.
Thank you, Neil, for the introduction. Hello, everyone. I am March, and I'm a PhD student working with Neil and ASSISTment. And actually, let's start. Let's get started. So first of all, in this paper, I use the term on-demand assistance to basically to cover a lot of things. For example, and in general, what I use the term is used to describe the type of assistant help tutoring that are provided to students when they work on online tutoring systems such as ASSISTment or mastery physics and things like that. But in this case, we only work on ASSISTments. So for example, on the left, you can see the problem on the top and the yellow boxes at the bottom. And these yellow boxes are what we call a hint set, which is a set of multiple helpful messages that students can request one at a time. And each hint message will obviously help the student solve the problem. In the middle, we have a different type of assistant that is available inside ASSISTment called an explanation. An explanation contains a step to solve that exact problem from the first step to the last step, including the answer itself. So it's a full solution to the problem. On the right-hand side, we have another example of an explanation, but instead of written out text explanation, we have a video from, in this case, Miss Jones, who is the teacher of that particular of that class. So it's a multimedia explanation that will help the student solve the problem. Why are we even talking about this? As Neil mentioned, a few years ago during the efficacy trial of ASSISTment in the state of Maine, we found one teacher in particular, which is Mr. LeSiege, who did something very interesting, which is he created hint messages for most of the problem he assigned to his students. But well, back then we allow this ASSISTment allowed teachers to create their own problems and share them with fellow teachers. We also provide a library of problems, for example, problems from, we also have problems from NKSU York, LeSiege Mathematics, and all other open educational resources. However, in order to prevent teachers from interfering with other people's work or accidentally modifying other people's work, only the owner is allowed to modify the problem, including adding hint messages. So what Mr. Efficacy actually did is he made a copy of all the problems he ever assigned to his students, and then add hint messages to all those problems. It's a very long and tedious amount of work that he did in order to help his students. So after seeing what Mr. LeSiege did, what we asked ourselves, Mr. Teacher like Mr. LeSiege is very diligent and hardworking, but what he did is he has to go through multiple steps in order to help his students. Can we better facilitate such teachers? The second question is, Mr. LeSiege also put a lot of effort into making hint messages, but it only helped his students. Wouldn't it be great if those hint messages are also available to students outside of his class that are using the same curriculum, the same, like all the other students working inside the same problem? Can we help them? In the field of educational research, we know that things like hint messages has been shown times and times again that are helpful to students. That's why we want to distribute them to students outside of his classroom, right? And however, only about one third of the problem inside ASSISTment has any kind of hint messages and other assistance at all. And most of the open educational resources that don't actually have hint messages because, well, they are initially they are plain text and not plain text. They are in a form of PDF and such, and they couldn't provide the hint messages. And also during hard times such as COVID, well, hint message would be very, very helpful for students who cannot interact with their teachers in real time. However, we also found a bunch of research that said, some type of hint messages may not be very helpful. And in this case, if we want to crowdsource hint messages, some type of hint messages might not even apply to students outside of classroom at all. For example, hey, remember, for this, use number 2 from the cheat sheet that I just gave you in class. That type of hint messages won't help students outside of the teacher's classroom at all. So after we think through all of that, we came up with 3 research questions. The first is, can we design and implement a crowdsourcing system that allows teachers to quickly and conveniently create on-demand systems such as hint messages for their own students? Well, and the second question is, if we were to crowdsource such on-demand assistance, how effective would that be? Third question is, we want to also make sure that we want to do good science. We want to make sure that the results that if the result that we get from research question 2 is actually real and reproducible, and it's not just a novelty effect of the feature. So we want to know if we were to try to reproduce the same result in a different academic term in the same system, will we get the same effect? And from now on, I'm going to refer to the crowdsourcing system as the TeacherASSIST. So when we look through multiple crowdsourcing systems, there are 2 major design questions that we have to answer. And in fact, any crowdsourcing system has to answer. The first is, we have to make sure that the user, in this case, the teachers, are incentivized to create on-demand systems. Because even successful examples like Wikipedia and Stack Overflow, they have an issue with insufficient contributors. And the second question is, there are a lot of things inside, even inside a single curriculum, there could be thousands of problems. Even within the same topic, there could be hundreds of problems. We want to make sure that the teachers are not paralyzed by the number of choices that and the number of things they could be creating. We want to make sure that the teachers can focus on things that are relevant to them. We did a few informal interview with the teachers, and we found that on the left-hand side is a specific page inside assessment. It's a page where the teacher come in and select the problems they want to assign to their students. So for example, they can click on problem number 1 and number 3 and assign it to their students. So what we did is we add little links that say, I want to write explanation or hints. And when they click on it, a simple interface will show that allows them to write hint messages or explanation. What's good about it is, instead of showing all the problems that they could write hint messages for, they only see problems that are directly relevant to them, which solve the design equation number 2. And also, since these hint messages are directly available to the students that they are literally assigning these problems to, is the teacher are incentivized to write these hint messages. After that, we looked at teachers who regularly clear content and quick to fix mistakes, and with that consent, we promote them to what we call star teachers, where their hint messages are basically crowdsource enabled and will be available to students outside of their classroom. So for example, let's say this is what happened. Purple teacher create 4 hints and so on. With star teachers, when, for example, the green teachers come in, since the green teacher did not create any hints for their students, students from the green teacher will receive the hint from the star teacher, in this case, the purple teacher. So what we did, after that, to answer the research question number 2, we ran 2 randomized control trials during the fall term and the spring term, respectively, of the 2018-2019 academic year. The control condition is the default, which is just a button saying, I give up, please show me the answer. And the experimental condition is the crowdsourced on-demand assistance. For example, the purple teacher in the previous example. And the dependent measure is the next problem performance of the student. In the experiment, we, instead of doing 50-50 split, we did 90 and 10 split because we strongly believe that crowdsourced assistance is beneficial to students. And the randomized control trial is run on a large scale, and we will have enough students, enough data to analyze the effectiveness, even with 10% in the control condition. And 4 dependent measures are the following. We actually only care about the first 2. The third and the fourth are included only to make sure that we didn't get positive result in the measure we care about, because most of the low performing students just give up and leave, and so on. So this is a result of the pilot study conducted during the fall term of 2018. And the result we found is that students are less likely to ask for help in the next problem. In other words, students are more likely to try to solve the next problem by themselves and eventually get it correctly without asking for hints, explanation, or give up and ask for the answer. While we don't get any significant difference in the other measures after we ran the corrected Benjamin D. Hopper corrected procedure, the raw number are actually in the positive direction, but we couldn't interpret much in that. Then we run the repeated study in the 2019, the spring of 2019. We get a bunch more hint explanation created, and the number of students also increased because of the bigger coverage of the hints and explanations. And the result we get is in the same direction with slightly stronger in terms of magnitude. So in conclusion, first question, well, we did create TeacherASSIST, and the teacher seems to like them. As we actually have seen, there are thousands of hints and explanation created even within a single term. The second question is, well, we did find that students are more likely to solve the next problem by themselves and eventually get it correctly without additional assistance. And even though we don't get significant result in the other measure, it also means that there is no significant difference in terms of the number of attempts that students make, which means that we did not sacrifice the number of attempts. Students did not bang their head against the wall and to eventually get it correct. They do it in roughly the same amount of number of attempts. And another thing we want to emphasize is the intervention that we did, the experiment that we did, we ran it on upper level. The randomized control trial is on the problem level, which means that even if the result is only 0.02 difference, is the effect on a single problem as opposed to a curriculum or a problem set in normal experiments. And the third question is, well, yes, we did get the same result after we repeated the experiment on a different academic term. And our code and data are publicly available in the Open Science Foundation website. We uploaded it. The slide is also here, and if you have any question, please let me know, and thank you.
Thank you, March. Actually, good job. I was trying to answer a few questions in the chat, but I recognize we're over. And I will just say that I'm super proud of March because we're now giving away all of these thousands of hints created by teachers to anyone coming to our site. But someone actually asked, was there deception? No, kids know that if your teacher wrote stuff, you get what your teacher wrote. It's only for the teachers that didn't write stuff are they part of the experiment.